Hey everyone, and welcome. Today, we are diving deep into a piece of tech that's completely changing how businesses look at their data, Apache Flink. You know, if you've ever seen something happen online and wondered how companies get insights that very second, well, you're in the right place. We're about to pull back the curtain on the magic of real-time data.
Seriously, think about it. In a world that moves at the speed of a click or a tweet or a credit card swipe, why are so many analytics systems still stuck in the past, waiting around for hours or even days for a report to run? That's becoming obsolete. The real question is, why should you have to wait at all?
And this really tells the whole story. On one side, you've got batch processing. Think of it like old-school film photography. You take a whole bunch of pictures, and then you have to wait and wait to finally get them developed and see the results. But on the other side, you've got stream processing. That's like a live video feed. The data is being processed constantly as it's happening. And that is the world where Flink shines.
So how do we actually get from yesterday's slow batch jobs to today's instant intelligence? Well, that's where our hero of the day comes in, Apache Flink. It's a framework that was built from the ground up for the chaos and speed of real-time data.
Okay, let's break down the official definition for a second. The phrase you really want to lock onto here is stateful computations over data streams. See, unlike some other systems that kind of cheat by just chopping data into tiny little micro batches to pretend they're streaming, Flink is the real deal. It's a true streaming-first engine. To Flink, everything is just one continuous, unending flow of information.
So, what gives Flink all this power? It really boils down to four main things. It gets the timing of events right. It can actually remember stuff it's seen before. It's incredibly reliable. We're talking exactly once guarantees. And, of course, it's built to scale out to massive sizes. We're going to see these features come to life in just a bit.
All right, theory's one thing, but let's see where the rubber really meets the road. We're going to look at a simple URL shortener as an example to see exactly how Flink fits into a modern data system and just brings it to life.
So this is a pretty classic, super resilient setup. First, your app creates an event. Let's say someone clicks on that shortened link. That event gets fired into Apache Kafka, which is basically a giant, super durable buffer for all your events. Then, Flink, our main character, grabs that data, maybe cleans it up, aggregates it on the fly, and finally, those real-time results get loaded into a blazing fast database like ClickHouse, all ready for a dashboard.
So how does Flink actually do all this work? Well, it runs with a master-worker architecture. The easiest way to think about it is this. The JobManager is the brain. It's the orchestrator. It looks at your code, figures out the best way to run it, and tells everyone what to do. And then you have the TaskManagers. They're the muscle. They have these things called task slots, and they do the actual heavy lifting, processing all that data.
Okay, so we get what Flink is and where it fits in the puzzle. Now let's talk about its superpowers. We're going to look at how developers actually build with it, and, crucially, how it's designed to handle things going wrong without ever missing a beat. For a lot of common jobs, like just moving data from Kafka into a database, you really don't need to write a bunch of complicated code. Flink SQL lets you treat those fast-moving data streams just like regular old database tables. You can write a familiar SQL query, and Flink just handles all the crazy streaming complexity in the background. It's an incredibly fast way to get things done.
But what if you need to do something way more complicated? What if you need more power? Well, that's where the Java DataStream API comes in. This gives you total, fine-grained control to write any kind of custom business logic you can dream up, manage state by hand, basically to build truly sophisticated applications that go way beyond simple data pipelines.
So how does Flink stay so reliable? Honestly, the best analogy is saving your progress in a video game. Checkpoints are like the autosave feature. Flink is constantly taking these little snapshots so that if a server crashes, it can just restart right where it left off. No data loss. Then you have save points. Think of those as your manual backup. You trigger them yourself when you need to do something big, like upgrade your code or move your whole job to a different cluster.
All right, we've covered the fundamentals. But the real magic of Flink, the reason people get so excited about it, is what it enables. So let's look at a few advanced patterns that are really only possible when you have a true stateful streaming engine.
The absolute heart of Flink's power is this concept of keyed state. You can just think of it as Flink's memory. It's the ability to remember things about a specific entity, like a particular user or a specific IP address, as new events for that same entity keep arriving. This idea is the foundation for pretty much every interesting real-time application out there.
And here is that power in action. A perfect example, real-time fraud detection.
We can literally tell Flink, hey, for each unique IP address you see, keep a running count of events. If that count for any single IP address goes over, say, 100 in 1 minute, we can fire an alert instantly. There's no waiting for some batch job to run overnight to tell you that you're under attack. You know right now.
Another super powerful tool in the Flink toolkit is the idea of windows. But we're not just talking about fixed blocks of time, like looking at data from 1 to 2 p.m. Flink can do what are called sliding windows. These windows actually overlap, which gives you this constantly updating, rolling view of your data as it flows by.
So what does that let you do? Well, think about any trending topics feature you've ever seen. With a sliding window, you can ask a question like, what are the top 10 most popular products in the last 15 minutes? And you can get a brand new answer to that question every single minute. It's how you build those live dynamic leaderboards and dashboards. Okay, here's a common problem. What happens when some of your data needs to go to one place and other data needs to go somewhere else? Sure, you could just process the whole stream twice, but that's super inefficient. Instead, Flink has this cool feature called side outputs. It lets you split, or branch, a single stream into multiple different streams all in one go. A fantastic use case for this is creating a dead letter queue. Let's say some events come in and the data's all messed up, it's malformed. Instead of just throwing that data away and losing it forever, a side output can shunt those bad events over to a separate stream for someone to debug later, while the main, clean data just keeps flowing on completely uninterrupted.
So, we have covered a lot of ground here, from Flink's basic architecture all the way to its most powerful features. But let's just zoom out for a second and talk about the bigger picture. Why is this whole shift to real-time so darn important?
When you put it all together, you realize Flink isn't just another data processing tool. It's a genuine streaming-first engine that's built for resilience. It unlocks these powerful, stateful applications, like fraud detection, that used to be incredibly hard to build. And it meets you where you are, whether you're an analyst who loves writing SQL or a programmer who needs that deep, low-level control with Java.
I think this quote from our source material just sums it up perfectly. Flink's whole purpose is to take what used to be a static, after-the-fact process and turn it into a dynamic, live intelligence engine that anyone can actually build and run.
And that really just leaves us with one final thought to chew on. Forget about dashboards that are hours out of date. If your data could actually talk to you, if it could tell you what was happening in your business, with your users, or in your systems right now, what do you think it would say? Thanks for joining me.